Hello and welcome to Climate Conversations. I'm Clare Nasir. On today's show, the latest scientific research around the future of heat waves in the UK. How often will we see temperatures peak above 40 degrees Celsius? The summer of 2022 began with a heat wave on the 15th of June. Temperatures soared across the country for 3 days. This initial burst of heat was merely a precursor to what would become a watershed moment in British climate history. The heat built again into early July, and by the 12th, the Met Office had issued an amber extreme heat warning. This was then increased to the UK's first ever red warning for extreme heat on the 15th. On the 19th of July 2022, the heat across the country intensified to a level never experienced before. A temperature of 40.3 degrees Celsius was recorded at Coningsby, Lincolnshire, the highest temperature ever recorded in the United Kingdom. Records were broken in at least 34 places across England on that day, 6 of which were over 40 degrees Celsius. The previous UK record of 38.7 held by Cambridge Botanical Gardens from July 2019 was obliterated by a margin of 1.6 degrees, an extraordinary leap in meteorological terms. Many locations broke their previous record temperatures by large margins as well. For example, Durham reached 36.9, breaking its previous record of 32.9 by 4 degrees. Scotland had its highest temperature ever after 34.8 was recorded at Charter Hall, while Wales saw its new national record of 37.1 at Hawarden Airport. There was a human cost. In total, across the whole of the summer in 2022, the UK experienced 5 heat waves, leading to 2,985 excess deaths across all ages, the highest heat-related mortality since records began in 2004. Fire services in England recorded at least 24,316 wildfires between June and August 2022. More than 800 fires were recorded on the hottest day alone, with London Fire Brigade declaring it the busiest day since the Second World War. And the NHS faced unprecedented strain, with emergency calls spiking dramatically. The significance of the 40-degree threshold cannot be overstated. Climate modelling shows that in a climate unaffected by human influence, it would have been virtually impossible for temperatures in the UK to reach 40 degrees Celsius. The July heat wave was an extremely rare event and was made 10 times more likely due to anthropogenic climate change. Before 2022, only 2 previous dates in the Met Office records had ever seen temperatures above 38 Celsius, just twice in over 150 years of observations. Enter Dr. Gillian Kay, a leading climate scientist at the Met Office, whose groundbreaking research has just provided some startling answers. Dr. Kay specialises in understanding the likelihood and dynamics of extreme climate events in the current climate. Her work has contributed to government resilience reviews and represents the cutting edge of climate risk assessment. Dr. Kay's latest paper uses sophisticated climate modelling to answer questions like, what are the chances of seeing 40 degrees again? Could we see even higher temperatures? And when we are under heatwave conditions, how long will a particular episode last? The findings are as significant as they are sobering, painting a picture of a nation standing at a climate crossroads, where yesterday's impossible has become today's inevitable. As we'll discover, the summer of 2022 wasn't an anomaly, it was a preview. Over to Alex.
Thanks very much, Claire. Now, Dr. Jillian Kay, I've been desperate to talk to you ever since I first heard about your important work. Now tell me first, what's your background in climate science?
I've had quite a varied career in climate science. I began by looking at projections of climate change and how they play out differently in different parts of the world. I've also been interested in how the climate system interacts with our land surface, so changes in climate, what effect that has on our vegetation. And then from the other way around, looking at how changes in the vegetation then influences the climate, both locally and at a larger scale. But more recently, I've been interested in much shorter timescales. So on top of climate change, you've got variations in climate from year to year. And I'm interested in the mechanisms behind these extreme events that we see, like droughts or high rainfall or unusually low or high temperatures. And then also the probability that these extreme events will occur in the climate that we have today. For a resilient society, we need to know more about the kinds of events that we need to be resilient to. And that's not just decades or 100 years into the future, but today. You know, we keep seeing news reports of record-breaking events. And what I'm interested in is whether we could have anticipated that those sorts of events could occur, and maybe even more severe events, so that we can be prepared as best as we can, you know, if and when they do occur.
So all about knowing what's already happened and seeing the impacts of it, and seeing if we could have seen that was coming, and then seeing the chance of something similar or more severe occurring in the future.
Yeah, or even you know, even today, even this summer, or you know, in very near terms, in upcoming years, what could the climate system of today throw at us?
So your recent report looks at the chance of us getting 40 Celsius again here in the UK, but it uses a large climate model. Could you tell me more a bit about that and how they work?
Yeah, okay, so we had our 40-degree day in July 2022. And
an extreme day.
Yeah.
I don't know about you, but I didn't expect it to happen anytime so soon.
No, I mean, it was only in the last few years that sort of it was mooted as possibility. I don't think you have to go back very far for that to have been sort of outside the realms of imagination for the UK. But and in the event, it was extremely well forecast, you know, in the days leading up to the event itself. And we had the red weather warning put out by the Met Office, and then in collaboration with the UK Health Security Agency, the highest level of heat health alert was put out. So, but, you know, could we have anticipated that event was possible in the climate of 2022? And so, you know, it's happened now, and I'm interested in questions like, you know, was that a drop in the ocean? Just a one-off? When might we expect to see that again? And could we see even higher temperatures, more intense heat waves than we saw? And this is in the climate of today. And questions like that are quite difficult to get a handle on, because we've only got one instance in our record of that 40 degrees. And so one way to look at this is through using a large climate model ensemble. So this is a large set of simulations of the climate model being run repeatedly.
Yeah.
And what that does is it gives you a much fuller representation of today's climate, and also how that has changed over the last few decades. So instead of just having one set of observations, we've got a whole lot of them, of kind of plausible, alternative, synthetic or pseudo observations, if you like. And from those, we can get much more robust statistics on the chances of seeing 40 degrees again, in today's climate or in sort of upcoming years. And also it simulates temperatures that are outside of our experience. So
even higher temperatures?
Even higher. So the model simulates several degrees higher than 40 degrees. And as a sort of a plausible temperature that could be reached in today's climate.
So is that one of the biggest surprises about your research, that those kind of higher temperatures are possible?
Yeah, I mean, there were a few things that stuck out to me with this research, and one of those was that, you know, more intense, so higher temperatures than we've seen could occur in today's climate. And it was also the rate of change. Okay, so the chances of seeing 40 degrees has increased since the 1960s, the start of the period of the study. But not only has it increased, but it's accelerated. The chance is accelerated. So, I mean, in the 1960s, the chance of 40 degrees was very, very small, sort of vanishingly small. But the 1980s, it was kind of like a 1 in 150 year or so event.
So very unlikely, not out of the question.
No, not out of the
unlikely.
question. But it would be a very rare event. And then the final year of the study, which was 2023, it was sitting at 1 in 24 years. But that is increasing. We're not sitting in a stable climate. We've got continuing change. So we would expect that change the rate to increase into the future. That was one of the outstanding features for me of the research. Another one was that the model was simulating much more prolonged heat waves. So, you know, we have lots and lots of examples of how the summer evolves, simulated by the model. So we can look at throughout the summer season and see each day what the temperatures could do. And, you know, 40 degrees, quite rightly, had a lot of attention. It feels like quite a milestone. But it's not like impacts begin at 40.
No, nothing drastically changes between 39.9 and 40.0.
Exactly, and the Met Office has heat wave definitions, so it's 3 consecutive days where temperatures exceed a threshold, and those thresholds are much, much lower than 40 degrees.
Than 40.
Yeah, it's like between 25 and 28 degrees, depending on where you are in the country, what sorts of temperatures you might be accustomed to.
And anything above that, people are
Exactly,
struggling.
Exactly. So we also looked at, you know, those lower thresholds, which are still impactful, and saw that we could have really extended periods of time above that threshold, like over a month, you know, day after day, temperatures above that heat wave threshold. You know, there's a well-established link between high temperatures and adverse health effects. And so some of these different scenarios or storylines, I think, could potentially be really useful in assessing how health, to give one example, could be affected both by the really intense high temperatures, but also by these prolonged periods above a heatwave threshold.
And so why is it that we're seeing not only a greater chance of these higher temperatures and the longer hot periods, but why is it that we're seeing the chance of that increasing and increasing and increasing at an accelerating rate?
Well, so part of the story is climate change. We wouldn't see these high temperatures and these really prolonged periods without it. But also, it's important to understand the role for circulation patterns. And that's a really nice thing about this method, is we're using these climate models, which are global, and we can look at what causes these extreme events, what are the circulation patterns associated with these exceptionally high temperatures. And to give an example of these, temperatures above 35, 40 degrees, these really exceptionally high temperatures over the UK, we've seen that an important feature is to have persistent high pressure over the whole kind of northwest of Europe. And that allows, over continental Europe, temperatures to build. And then when conditions are right and we have, southerly winds coming up, we can, the warm air masses are drawn across the UK, and that's what gives us our really, really high temperatures.
So I suppose, like with all weather events, it's not just climate, it's also the bigger
Exactly.
patterns.
And I think it's a big important question for future research, is that interplay between the circulation patterns and the kind of underlying climate change signal. If we happen to get more of these events where we have winds drawing the warm air masses across the UK, what effect would that have on our temperature records here?
Now, just in the report, it talks about the fact that in the next 12 years, there's a 50-50 chance of us exceeding 40 Celsius in the UK. What does that actually mean?
So what we did is we looked at that changing rate of getting 40 degrees in the UK and said, okay, if we continue at that rate, how will that likelihood of 40 degrees change? Because I've said that rate of change is accelerating. And so what is a 1 in 24 year return period in 2023? We'd expect that to continue to shorten as we go into the future. And there is a lot of uncertainty about how that will change in the longer term. But if we're just looking out in the next few years and say, let's continue at that rate that we've seen in the last decade, and what will happen to the return period as we go forward. And it does continue to shorten. And this 50-50 chance of 40 degrees in the next 12 years, that is coming earlier than we would have expected given a static return period, an unchanging climate. So it's happening, that 50-50 chance is happening earlier than otherwise.
Because our climate continues to change.
That's right. Yeah.
In arguably the wrong direction from many people's point of view.
Yeah.
What kind of concerns does this suggest for the UK? So a greater chance of seeing 40 Celsius. What does that mean for us?
Well, I outlined some of the effects on health, and I really think that it would be great to partner with expert organisations in public health and epidemiology to really understand what those really high temperatures and the extended periods of heat would mean. But also other sectors are likely to be affected, water and agriculture, transport, energy as we go forward. And I think that these plausible storylines of how the summers could look could be really useful in stress testing existing systems and maybe helping to identify areas where for further development would help improve our overall resilience.
So is that something you and your colleagues are looking to do, work with other
Yes,
areas?
that's what we're hoping to do.
Yeah, to find adaptations, I guess, for this changing temperatures.
Yes, that's right.
And is that something that you see there being positive steps that we can take in the near future, both in case of, because a lot of when it comes to climate change, we talk about things that individuals, businesses, etc., can do to minimise our impact. But we really need to be talking a lot about what we can do to adapt to the changing climate.
I think that's right. And I think that having additional information will help to develop these strategies for a more resilient society.
So going forward with this report now out, what responses are you expecting from various industries, the farming industry, for example? What response do you think you're going to get?
I would hope that this report will provide useful information for a whole range of different sectors. I mean, these are all plausible alternative ways that our summers could evolve today. This is not projections decades into the future. These are things that could happen today, and so could be useful in helping to plan a response or take strategic action in the case of some of these high temperatures and prolonged heat waves that the model is suggesting are possible.
And do you think the appetite's there? Do you think they want this information, or are a lot of industries stuck in their ways and want to just continue head in the sand, I
Well,
guess?
I think we need to partner with umbrella organisations, because you're right. I mean, we don't, as a research group, we don't have direct links with these different sectors, but as an organisation, we do routinely partner with different organisations, research bodies, and so I think it's through those paths to see whether this particular information could be useful, or whether some other research kind of inspired by this particular study could then be adapted to be more useful for these different sectors.
Now, how reliable are climate models like the ones used in this research?
I mean, they're models, and so they are, like all models, subject to uncertainties, but we do rigorous testing of the models for the particular application to see if they can be used for that particular purpose. And if they can, then they can be treated as a large event set that can be mined for all sorts of information, some of which I can only guess at, but in collaboration, hopefully it can be a useful source for all sorts of different applications.
And are the figures that you're coming out with and you're looking at, are they worst case scenario, or are they what we're expecting?
Worst case scenario is perhaps a slightly tricky term. These models give us lots of plausible alternatives to what we have seen in our observations, but they're unlikely to provide the full range. But I think that they could, some of these scenarios that I've been describing, or the storylines, could be seen as plausible extremes to be used as case studies for stress testing different systems.
And with the 40 Celsius, when we recorded it before, it's in the southeast of England, and that's the most likely area that we're going to see it again. But it's not the only place where we're suggesting extreme temperatures are going to happen.
No, not at all. So we focused on the southeast of England for part of our report, because, as you say, it's the most likely to see those temperatures again. But anywhere in the country, we could expect to see temperatures that are outside what people are used to, and could have serious adverse impacts on a whole range of activities and on health and so on. And so a similar kind of analysis could be done for anywhere in the country.
And is it possible that these models, they're underestimating the effect that we're going to see, in as much as the story has changed a little bit that we're likely to see higher temperatures sooner, or there's a greater chance of seeing those higher temperatures sooner. So is it possible in 2-3 years' time that it's even closer than we thought?
Yeah, it could be as we look into the future, and particularly further into the future. There is uncertainty on what path we take, and that is going to have a profound effect on the sorts of extremes that we see. So we could potentially see higher and higher temperatures as we go on.
That's really interesting. It's opened my eyes to a lot of things. What are your next steps? So we've talked about reaching out to other areas of expertise, but where do you go now in other research?
One of the things I am interested in is this interplay between the climate change trends, sort of underlying trends, and the circulation pattern. So this climate change and climate variability, the role for weather patterns in producing some of our extremes of climate. So I would very much like to look in greater detail at that. But the models that we use there are global, and so there's potential to look at extreme events around the world, and indeed we have done that to a certain extent. It depends on the extreme of interest, but some kind of similar analysis can be done for in all sorts of different contexts. So giving better information about the probability of seeing certain extremes of interest, and also providing these multiple simulations of how a season can evolve. I think both of those things could be useful in lots of different ways.
Thank you so much, Gillian, for joining me today and talking about your really important research. It's been incredibly interesting. Thank you again.
Thanks, Alex.
Our thanks to Dr. Jillian Kay. For more information on the scientific paper just discussed, please go to our Met Office website. Thank you for watching Climate Conversations. If you enjoyed the episode, please check out other shows in the series, and Alex and I will see you again soon.